Welcome everyone to SQL Friday. This is SQL Friday number 17 and our star for today is Jeff Moden. Jeff is going to talk about generating test data to be able to actually test your code properly and see that it performs well. I have read a lot that Jeff has written on especially SQLServerCentral.com. And it's inspired me to make a presentation which I called RBAR bad, sets good. I think Jeff is probably the person that has influenced my performance tuning skills or T-SQL performance skills the most. So it's really an honor to have you on, Jeff.
Thank you, sir.
The stage is all yours.
Okay, let's go into the screen sharing mode here. And I'm not legally alive yet. It's only 6 o'clock in the morning here. So, okay, as Magnus said, and I watched Magnus's RBAR bad, set base good. And that's how I got in contact with him about possibly making a presentation for SQL Friday. And so here I am, and I love prime numbers, so I'm glad today's SQL Saturday, number 17. Let's see if this works. Great. Here's a little bit about me. You can read this on your own. One of the things Magnus said was he thinks I was the guy that coined the term RBAR, and yes, I'm here to tell you I am. RBAR stands for Row by Agonizing Row, and it has to do with how a bit of code is written, and it doesn't just mean while loops, it means recursive CTs, recursive functions, just a whole bunch of things. Or it could actually be something that looks set-based, like a triangular join that isn't set-based, and basically anything that touches a row more than once is row by agonizing row. I'm also, I didn't invent a tally table or a numbers table, but I helped make it kind of a household name. It used to be a very advanced topic, and everybody guarded it like it was some secret. And I said, I've had enough of that. I use it all the time, and I was getting ready to make a presentation that relied on it heavily. So I wrote an article on SQLServerCentral.com that turned, instead of it being a black box, it turned it into understandable code. I also have to say SQL Server is both my profession and my hobby. And yeah, I know I need to get a life, but I have a face for radio, so I don't have much of a life. So here's a question for you. What is the difference between poorly performing code and high performance code? Now, you might think that since I'm a two-fisted anti-RBAR type of guy, that the answer would be one has RBAR and the other doesn't. But the real answer is, unless you have enough test data of the right kind to test with, you'll never know because you're just guessing. Okay, so an agenda. We're going to talk about the contents of the zip file, why learning how to make test data is important, problems with testing, in specifically the how you cannot rely on the execution plan to determine which is the faster code, problems with testing, and specifically we're going to cover some Holy Grail articles, and the reason why is because what you see is not necessarily what you get when you're testing on your desktop or whatever. It can be quite different than production if you haven't made the correct test data, and I have an example that will drive that point home so hard it'll hurt. We're also going to talk about some accuracy problems with testing, because when you make test data, you have to make test data that tests for accuracy as well. Performance problems with testing, and then just a quick introduction into looping and counting. It's so fundamental to the computers, it's unbelievable, and T-SQL is no exception. And then an introduction into what I call pseudo-cursors. That was a term introduced to me by a fellow by the name of RBAR over on SQL Server Central. And then we're going to talk about when random numbers aren't random, because a lot of people end up using RBAR trying to make random numbers because they don't know how to make it without using RBAR. It's all due to the rand function. And then we're going to get into the meat, and that's where we can create some random number generators. And it's actually quite simple. All of this is a prelude to random number generators and code examples. Now, something else I want to tell you is when I do a presentation, I break every rule of presentations in the world. One of the things people say is you should be able to put 6 bullets on the screen and talk for an hour to that. And my answer is yes, I've been there and done that, and I can do that. But if you've ever gone looking for some help or something and you find a presentation and then you go to look at the PowerPoint presentation and you find 6 bullets and nothing else, it's very disappointing, especially if the video is broken, or if you're in a hurry, you don't want to have to go through the whole bloody video. And so I don't make PowerPoint presentations. I make animated PowerPoint books that you can play back later on, and it will be almost as if I'm there, because you'll see some things popping up and everything, but hopefully it'll be very clear and you won't need me anymore on this particular subject. Okay, contents of the zip file. It looks like that, and this first thing is an SQL performance monitoring template that I use. And yeah, I'm one of those people where you will have to pry SQL performance monitor out of my cold dead hands before I use extended events. We have a function that replaces recursive CTs and while loops. It's based on Gon's good work, but I've modified it to not be as scary in the execution plan, and it runs a little faster as a result. Then a whole bunch of code examples. We'll go through each of these code examples during the presentation. I also have this PowerPoint. The presentation is a slideshow, so if you don't have PowerPoint, you can still see the presentation. And then, of course, this presentation in PowerPoint. Okay, a lot of people say, well, why is learning how to make test data important? First of all, we know that code accuracy is a must. It's got to function properly, it's got to produce accurate results, and the amount of test data needed to test for accuracy can typically be the proverbial 10 rows. You don't need very much data very many times to test for accuracy, although there are times where much more is needed, and this presentation will help in that area. There's also performance. A lot of people say, well, performance doesn't matter because I have all night to do this run. And I tell them, yeah, but someday you're going to run out of hours during the night to do runs, so performance always matters. And if you look at any SQL form, half the post asks how to do something, the other half the post asks how to make something faster. And so people that go, well, performance doesn't matter and milliseconds don't matter, yeah, you're going to think performance is important. And if you're like any other good DBA, it'll probably be right around 3 in the morning. In the long term, good enough usually isn't, even on the small stuff. And we'll see that with recursive CTEs as well. But one of the problems that I'm having, even after years of working for the same place, is the death by 1,000 cuts. And this is where there is no high ROI point where you can go in and make one fix and all of a sudden everything runs faster. Instead, every cotton picking select in 1,000 line or 2,000 line stored procedure is a performance problem and you have to fix them all, the best thing to do is, well, first of all, you in this presentation, you're going to learn how to build enough test data so that you can help figure that type of thing out. But what I really hope for people to do is, it's worth doing right the first time so that you don't get wounded by this death by 1,000 cuts. Performance and scalability are always on my mind when I write code, and the easiest way to check for performance and scalability is to have enough test data. But enough test data isn't the only thing you need. You have to have the right test data, and I'll prove that here in a minute. But there's a thing I call grooved test data, and it's not good enough. We'll find out that grooved test data is incredibly easy to make because people are lazy. And it sometimes takes a bit to make good test data, but I have to tell you that the secret to my personal success has been to be able to make test data rapidly, even if it's for something small. It doesn't always have to be for something big. Problems with testing. The execution plan lies. This is one of my favorite parts of this. And the execution plan doesn't actually lie. It just can't tell the truth, because even the actual execution plan is riddled with estimates. And we'll see more on that here in just a minute. My point is you can't look at an execution plan and say, well, if you look at the excuse me, if you look at the execution plan for two different pieces of code, maybe even on the same screen, you can't make the decision that one will be better than the other, because the execution plan changes based on the number of rows, the cardinality of the rows, and like I said, even the actual execution plans are just totally riddled with cost-based guesstimates. Now, if you look in the upper right-hand corner, you should see a little demo button, and just to the left of that, you'll see a file name that comes up. And that means I have a demo, and the file that I'm going to use is that particular file name. And if that file contains demos from more than one page, how will you know which page it's for? It's real easy. You look down here at this page number, and if this demo has more than one page worth of demo in it, all you have to do is look for the word page, space, and that number, and alrighty. So here's page 13. This is script 10, the execution plan lies. And before we actually run this, I want to show you something really cool. Here we go. If you notice, I have this JBM tester.tdf. TDF stands for, gosh, it's too early in the morning for me. Well, it stands for template, and I forget what it stands for. But that's actually an SQL performance template. And if you double click on that, it's an SQL profiler template. If you double click on it, it'll install it for you. And that also brings up SQL Server Profiler. And we'll talk more about that in just a minute. The other thing I want to show you, and I forgot to open it up, but let's open it. I'm sorry, I got that upside down for you. Here's this effing tally, and you can install this. I don't normally put quota identifier and set ANSI nulls in here, but that's a setting that's essential, and I don't know who else is going to run it. And it is based on Itzhak Ben-Ghan's virtual auxiliary table of numbers. And I ran into a problem like he did, and he and I both thought that it was fixed, but the code itself is actually very, very short. don't let this scare you. This is an optimization. There are 256 ones there, 16 per row. But this keeps parallelism from killing you. When you're starting to work with 1 million or 2 million rows, parallelism will kick in. And at that level, it kicks in too early. You can change that a little bit by setting the maximum degree of parallelism on your server. But if you don't get it right, you could end up with things that take quite a while to run. And this basically has 4 cross joins of that this 256. And so what I do is I calculate the number of ones that I need in any one of those by, this is how you take the 4th root of a number. We're actually using 0.25 as the root, and that calculates the 4th root of the number and adds 1. And this is what we call a roll goal. And so it's selecting that many ones from at max n. And we'll see more about that. But also, a lot of people make these where they're super flexible, where you can have a start number and an end number and an increment and all that kind of stuff. And I didn't do that. And the reason why is because about 99.5% of the time, you want to count from 0 or 1 up to some maximum number, and you don't need a bunch of other stuff in here slowing you down. And it will create that many number of rows, which is the entire, if you were to count the range of ints, it goes from -2 billion to +2 billion, and this covers that number of rows. Okay, let me close that. And getting back to here, we had loaded that SQL profiler template, and what I want to do now is show you how to use it. So I went to Tools and the SQL profiler, and I do my normal connection. And what you want to do then is, it's there in the selection. You can just select it as a profile because it was installed. And I didn't name it JBM Tester to be pompous or arrogant. I just figured nobody would be naming a template with JBM in it, so I wouldn't be overwriting anybody's stuff. The other thing is, if we take a look at this SQL, right up here I'm on SPID 77. And so to make this as lightweight as possible, if you're working on a shared environment like a dev environment, you want to go to the events selection, and you can see I'm not collecting very much data. This is extremely lightweight, but if you're working in a shared group, then you want to go to the column filters and already have a SPID filled in here. All you have to do is select SPID and put your SPID in and press enter, save side, and then say OK. And then you can do a run, and you're ready to rock and roll, and you're only collecting stuff about your run, not everybody else's run and the system, etc. Okay, so I'm going to run this code just so you can see it has a recursive CTE that counts from 1 to 1 million, and then we run the tally function from 1 to 1 million, and I'm going to turn the actual execution plan off and run this. And it takes 6 seconds to run. Sorry, that 6 seconds took so long, right? 5. Okay, and then I'm going to turn the actual execution plan on, and I'm going to execute it again. And there's a method to my madness here. And you notice with the execution plan on, it takes a little while longer, and I'm going to stress that a little bit. Okay, so which is better? And if we go and we take a look at the actual execution plan, a lot of people will judge things by looking at this relative percent of batch. And oh my God, this is part of the reason why recursive CTEs look so good. If you compare it with any other code, they come up with 0%. They must be good. You know, this is pretty nice looking. It's nice and small, and and this uses ITSEX code. If we look at ITSEX code, oh my God, it took 100%. That's got to be some sucky code, right? And you can say, okay, why did it suck? And you look at this plan, and nice and short. And if you look at ITSEX plan, it keeps going and going, and I'm going to bore you, and going and going and going. There's actually 31 nested loops because he cross joins 32 subtables. And so we think we found the problem, but let's go look. Profile run. Now I'll explain how I get these nice lines to show up here in a minute, but here we have the recursive CTE, and we can see the duration is what took longest in that run, in the run of 5,593 milliseconds versus 209. We can see CPU followed the same suit pretty much. Down here, we can see that we had been doing the run with the execution plan on and off, and we can see that that made things run a little bit slower, but on really good set-based code, the execution plan will frequently make the set-based code run more than twice as slow. You can see we had 209 and now we're at 585. So what about reads here? Look at this 90 sitting here. That is, ladies and gentlemen, more than 9 million reads. And what I want to do, let's see if I can get back here. And I can't, so I gotta drop some of this down. Oh my God. I can't get to my calculator easily, and instead of wasting your time, let's go back over that. If you break out your calculator and take that number, that's the number of logical pages that are read, and that logical page is 8 kilobytes. And it turns out that there are 128 pages in a megabyte. So if you take that number in a calculator and you divide that number by 128, you'll come up with 70,000 megabytes. Another name for that is 70 gigabytes. The recursive CTE takes 70 gigabytes of memory I/O to count from 1 to 1,000,000. And you can see the tally function took much less, and it actually didn't take that many. It actually took 0. This is from the writes that it did to the table. So let's get back over to that. So how could this be? We've got this monstrous ITSEC Ben Gone execution plan and this nice little thing here. Well, let's take a look. Here, it says actual number of rows, 999,999, and that's correct. Estimated number of rows per execution, 1, but the important part, is it says actual number of rows. Here, actual number of executions. Good. Here, okay, actual number of rows for all executions. Those are some pretty good estimates. Here, yeah, that's correct. Actual number of rows, even here. This is the static part of the CT. 1 row. But if we go here, estimated number of rows per execution, 1. Estimated number of executions, 5. Same thing here, except it's 4. This, this bad boy right here. That right there is the recursive part of the CTE, and the estimate is based on, if you look right here, 20 rows max. It's actually close to one iteration of the CTE, and this is why CTEs look so good, and this is why you cannot and must not look at the execution plan and say, well, obviously the top one is better because it has the shorter execution plan. That is just an absolute lie. You cannot rely on it and to tell you which code is actually going to be the fastest. You have to use either extended events or an SQL profiler run. Let's go back here. Magnus, any questions on that so far?
No questions so far.
Cool. That means I'm actually doing my job. Okay, so never use the execution plan. It is really good for designing and coding hints, like which indexes it's using, but you cannot rely on it for performance. And just to recap, it looked like the execution plan for the RCT was, or recursive CT, was really good, and that ITSIX code was going to suck real bad. But then we looked at that and we found out we only have a partial estimate here, whereas ITSIX is a full estimate. And we found out that the actual run tells a whole nother story, and so you must actually do a run. You can't. Look at this. This is nuts. Okay, and I got that. Excuse me. Okay, problems with testing. This is kind of like part 2 for this. So we have Holy Grail articles. Now, what a Holy Grail article is it contains code to, you're looking for a problem and you find this article, and this article has code to set up some test objects, some test data, code to measure accuracy. And we call that an accuracy test harness, code to measure performance, and performance test harness. And then they put in charts and graphs to show all the results to prove that one method was better than the other. And I have to tell you, you have to be really, really careful about the Holy Grail articles. And the whole reason is because of the test data that they use. So first of all, I love QA people. You QA folks in the background, if you want to, you can take a picture of that, because I love QA people. They find problems they can't even think of. It's amazing. Their job is to break things, and people have to understand that, and the breaking things helps us. So here's an example from a Holy Grail article. The data that they had was this particular example, example string, where we have Patriots, Red Sox, and Bruins, which are sports teams in the United States. And the task was to split the strings at the delimiters, the commas in this case, and return the individual elements. And the expected results were 1 row per element, as you can see here. And there were a whole bunch of different functions to be tested, but because one of them is mine, I'll bring that up. It's delimited split N4K, which uses a classic inline tally table, which we'll talk more about. And that was versus a thing called split strings XML, which uses a classic XML method to split the strings. This is the, just in case you wanted to know, that's the delimited split N4K function. Looks kind of complicated. Obviously, it's going to run slow, right? And here's the XML function. Very short, sweet code. Obviously, it's going to run very fast, right? Okay, so testing these two functions for accuracy is pretty simple. All you have to do is create the data on that first row there, and then test one function, and then test another function. So my question is, okay, what's wrong with that? The results of each function came up with Patriots, Red Sox, and Bruins as expected. Where's the devil in the data in that? And this is, again, why I love QA people. The devil in the data is actually that it's missing test. There was no empty string test, no blank element test, no null element test, or any of these other tests here, and it's just crazy. And I probably missed a test or two here, and you wouldn't think that there'd be so bloody many tests for doing a simple thing like splitting parameters on a comma. So I made some much better test data for testing this. You'll see what they had for testing it. Well, actually, I already showed it to you. But this is the actual test data, and this is the test name. And so I ran the code again against those things and came up with some slightly different results. To be mild, there's some horrible failures. So I ran delimited split N4K using that other test data, that test data table. And I used select star instead of just one column that was supposed to be coming back from the functions. And same thing here, these two pieces of code are identical except for the function being tested. And for delimited split N4K, the results were what I expected. We have several columns here: string, test name, item number, and item. And item number? Interesting. To give you an example, we have a group of 4 items split. The test data here has a leading delimiter, which means that there's an empty element here, and then the word leading, then the word trailing, and then a trailing element. And that pulled back all 4. You can see the blank, the leading, the trailing, and the blank as the item result. And then we also have some pretty awesome unexpected functionality. We actually have the item number of each row from left to right, the element number, if you will, and that's a whole column. We've been trying to get Microsoft to change string split so that it would include these so that you can be guaranteed a sort order.
Did they say anything about that?
They say the same thing that they normally say on these types of things. Yeah, we're considering it. And yeah, it's been 4 years. It's like the tally table connect item, which is now a feedback item. It's 11 years old, and they don't understand the need for it. And if you look at things like the slowness of the format function, they'd probably screw it up anyways. So anyways, this was a test for an embedded delimiter. We can see it's a true CSV with quotes on it and a comma. And it wasn't handled by this, but it wasn't a requirement to be handled. And this is what I'm talking about here. The QA people, they're going to try to break your stuff. Don't get mad at them when they do, and they will. They're just trying to ferret out, have we met all the requirements? And are there any requirements that might be missing? They will save your life. And then we have an all characters test. I only have one odd character in here. We need to really watch that row in the next test. And then we also pass in a null. Excuse me. Sip of coffee here. Normally when you pass a null into a function, you expect to get a null back, and that kind of indicates that you hit the function, but there wasn't anything to hit it with. And this particular function does that. So we need to watch that in the next test as well. Everything else will show up pretty much the same. Here are the results from the substring XML. And here's that same group of 4 items, and it produced 4 rows just like the other string did, or the other function did. But note that nulls are returned instead of empty strings. Now that's neither right nor wrong, but it's something that you need to be aware of. And my recommendation is that you really need to decide what the requirements are going to be at this point, because we have two functions doing two different things. So, like I said, not necessarily bad, but it is a difference that may matter. If we look up here, do you see that null input anywhere? The answer is no, it's not there. It doesn't return anything if you pass it a null. That could be a big problem depending on what you're doing. And like I said, generally speaking, and this is also a problem with the string split that Microsoft wrote. If you pass it a null, it doesn't return anything to say, yep, you've got a null as confirmation. It also doesn't have, and this is why I do select star when I'm testing, it doesn't have the item number column. It's as bad as string split because it's missing that. No ordinal column. And like I say, it's not a requirement, but it should have been, especially on the Microsoft side. And then, it looks to me like we're missing a whole bunch of data. Where's the rest of that data? Well, you remember the Mr. and Mrs. in the test code, or I should say the test data? Boink. That's what happens, and that's what the author didn't include in his testing to show that his XML string splitter would work. And what really bothers me about this is this has become very, very prevalent, and a lot of people are using this, and they just don't know what they're in for. As far as I'm concerned, this function is a failure. Now, if you think that's bad, there's some problems with performance testing, and in Holy Grail articles, frequently what you see is not what you actually get when you move something to production. So I want to introduce you to a term that I call grooved test data. So in testing the XML splitter versus the delimited split NK splitter, excuse me, the lungs are finally starting to work. I think I'm becoming legally alive. That same author wrote a table that looks like this. So far, pretty good. It's got a row number and a string with nvarchar 4000. And then he populated the table with test data. And do you see anything wrong with the data that it creates? I mean, after all, if you look here, there's 11 elements here, and then he does a replicate of 10 for a total of 110 CSV elements. What's wrong with this picture? And he certainly got enough rows here. He creates 100,000 rows. And I have to tell you, anytime you see a performance article with a Go some number in it to make test data, you might want to consider looking at a different article. And you'll see why here in just a minute. But that's pretty good indication that the author has made incorrect test data. Let me show you why. So in the article, the test seemingly proved, which is why I have in quotes, that the XML splitter was faster than that tally table splitter. And if we take a look at the results in SQL Profiler, and tally table and delimited split and 4K are the same. I actually changed the names partway through. But we can see the duration averages about 4.7 seconds, and CPU follows suit. Reads aren't too bad for 100,000 rows. And if we look at the results for the XML splitter, wow, it's about 25% faster or so. It's averaging, I don't know, 3.3 seconds. That's not bad. It only uses the same number of reads as the tally table method. So that's very, very encouraging for the XML splitter. But here's what happens with if you try to put something like that into production. If you look at the tally table splitter on 100,000 rows, it took 25 seconds, and you think, wow, that's kind of long. Well, it's doing a lot of work. And if you look at the XML splitter test, ladies and gentlemen, that is actually 483 seconds, because this is in milliseconds. That's over 8 minutes. That's 8 minutes and 3 seconds to do exactly the same thing as what the tally table did, the tally table function did. So What was the difference? The difference was the test data. The test data that the other author used looked like this. All the rows are the same, and that's why I call it groove test data. You can actually see the vertical grooves in there. It looks like rows of corn being plowed. It's not realistic, and all these rows are exactly identical. They have a cardinality of 1. It turns out that XML likes that really, really a lot. It can take advantage of that, and the production data actually look like this. Totally random, and it has a cardinality of 100,000 out of 100,000 rows. Like I say, the XML loved this test group data, and so what I'm trying to point out here is not only do you have to have enough test data to measure performance with, you have to avoid groove data. You have to have data that looks like production, and so that means you have to get good at making test data. Bottom line is, developer must never guess. Execution plans won't tell you what the fastest code is, and if you use the wrong test data, it's going to burn you. So you have to know. A good friend of mine from New Zealand, Sergi Flocka, kind of said that in 2007. I've taken it to the hill. Actual run results are the only way to know things for sure. If you don't have actual test data, you need to build some, but just having a lot of rows doesn't suffice. You have to build realistic test data or get burned at the stake when it goes to production. There's also some serious side benefits. There's a lot of people that go, well, in my humble opinion, I've got 20 years of experience and recursive CTs are the best thing to use. Yeah, Homer, I got your 20 years of experience right here. Here's a test that proves that you're absolutely wrong. It also makes you smarter about things like the code you're testing, because you have to look at the code that you're testing and decide what the test data needs to be. It's going to, excuse me just a minute. My apologies. It's also going to help you with writing code in general, because we're anti-RBAR with all our stuff, and there's some extensions you can use for this in real coding. Lots of data generation tricks that can be applied. And another code, one of my favorite interview questions is, I have a whole bunch of data for a month, and I want to get a sum for each day, but we don't have data on every day. How do we show that we have zeros on those days if those days are missing? And the answer is, you need to generate the dates and then do a left join to them. So knowing this kind of information is actually going to help protect you and your servers from post-deployment disasters like the XML splitter. And probably better than that, it'll probably help people, prevent people from referring to your code using a single 4-letter explicative. And that explicative would be crap code. Angus, you got any questions that have popped up so far?
Nope, no questions.
Okay, and I figured I would ask you every once in a while, because there's nothing worse than presenting and losing a connection and not realizing you've lost the connection and you just spoke for a half an hour and nobody was listening.
Yeah, that sucks.
Okay, so anyways, it doesn't matter what we do in computers. Looping and counting is absolutely fundamental. But most people in SQL Server end up doing it as slow as molasses. And there's actually 2 ways to pronounce the word molasses. There's the syrup, and then if you see a bunch of this guy's buddies running down the street, you'll understand the other pronunciation of molasses. At the start of other computer classes, they teach you how to do the display world thing, and that just means that you're set up for programming and your environment works. They teach you some simple syntax and rules, and then they teach you how to loop by teaching you how to count. They'll say, okay, we're going to make a program that counts from 1 to 100. It'll be magic. In SQL classes, They don't normally teach you that. Or if they do, they teach you how to use a while loop or, oh my God, a recursive CTE. You'll never look at recursive CTEs in the same manner that you did before this presentation. But in those classes, they also don't concern themselves too much about performance or scalability. And that's absolutely wrong. They need to do that a whole lot earlier. So let's talk about counting in a loop. This is what they will normally teach you. Now, what you're going to see, if you're under 40, this may be close to pornographic. And if you're over 40, you may have some appreciation for it. But I can tell you, if you're over 60, you'll love it. Isn't that terrible? Most people don't write flowcharts anymore. I write them all the time. We have a routine name here, and this is the way a loop works. We might have some routine name, and that's the starting point. We have some presets. We do something. We add one to a counter. We ask if the counter has expired, if it's not expired yet. And if we still have more to go, we do the loop. And if not, we exit. That's how a while loop works. Cursors, I'm not even going to cover those, but they work about the same. They can just have a lot more overhead because they're automatic. Recursive CTEs, which I abbreviate as RCT. Static section is there. Recursive section is there. Basically the same kind of loop, and I have an article on how bad they actually are. We have a transactional while loop, which will actually beat a recursive CTE, especially for reads, but also in CPU and duration. And the only difference is between a transactional while loop and a while loop is just before they go into the loop, they do a begin transaction, and just after they come out of the loop, they do a commit. And the reason why it works so well is because instead of writing every row to the log file, it saves the log, all the rows up for the log file. And I'm sorry, it's writing the rows to the log file, but not to the final file. It's collecting all the rows, and then at the very end, it writes all the rows. And so it runs a fair bit faster. And I gave it away. The other type of loop is a select, because behind the scenes, SQL Server is nothing more than a very, very, very sophisticated file server. It has to, if you want to read something from a table, it opens up a portion of the file and does the old read a row, write a row thing. But it's done at machine language speeds. A select makes a great loop. And that's, excuse me. That's what I call a pseudo-cursor. You have a machine language speed loop behind the scenes, and you're going to use a recursive CTE. And now let's not do that. So quick introduction with pseudo-cursors, and I want to introduce you to a new phrase that a lot of people don't have in their code that you will have in your code, and that is, and you got to say it as dirty as it sounds, nasty fast. And it will be fast. Okay, select as a pseudo-cursor. You can use what I call the presence of rows to make a loop, and we'll show you more about that. But it'll blow while loops, cursors, and CTEs away. And select, insert, update, or delete can be a pseudo-cursor. You can also multiply the presence of rows, and we'll show you that. This is also positive proof that not all cross joins are bad. And then we'll also introduce you to testing as if you were actually running the code without displaying stuff, which is how code works a lot. You'll sit there and you'll crunch numbers, and you don't want to do the display when you're testing, because the display times will slow you down. I'll show you what I mean here in a minute. And a quick little intro to minimal logging. And we're going to build the clustered index before and after inserts, and we have a demo up here. So let's get over to that. Okay, so, and you can see what, the page numbers look like again here. This one happens to have a couple of pages. So first things first, and I normally don't have descriptions in the code here. This is something else I hate about Holy Grail articles, is that they give you a bunch of code but no explanation. You have had to be there to get explanations. But, if we run this code, what does it do? And the answer is, because of the select star, it returns all the columns, but more importantly, because it doesn't have any criteria, it also returns all the rows. Excuse me again. Okay, so and sys all columns is just a system view for all the user columns. So what does this do? Well, this is going to use the rows from sys all columns, but it's not using any of the data from sys all columns. I'm using the select to drive a custom loop. In other words, I'm only using the presence of rows in this view to drive my little loop here. And what this will do is, in this original code here, we saw that it returned 10,825 rows. This is going to return the same number of rows, but with the number 1. Pretty simple, 10,825. We can do some more exciting things, like we can give it a row number, and here's the right way to count, folks, without using a while loop. 1, 2. Oh, I'm sorry. 1 to 10,825. We used all the rows there. All right, so we want to do 1,000,000 rows, and we do the same thing, but we use a roll goal of 1,000,000. What happens? Well, it looks like it worked, but there weren't enough rows there. We only have 10,825 rows, and so we don't have enough to, gosh, I hear Teams beeping, and I hope that's not a disconnect. Magnus, can you confirm that I'm still connected?
You're still on.
Okay, thank you. We want 1,000,000 rows, but we don't have enough. So we break out the trusty row multiplier known as a cross join. Now, 10,000 times 10,000, you can see it up here. That'll give us up to 100,000 rows. We don't want, 100,000,000 rows. We don't want 100,000,000 rows. We only want 1,000,000. So we use top to set the roll goal. And you're going to see that this takes several seconds. I think it takes 7 or something like that. Yeah. To return the count from 1 to 1,000,000. And let's just go down here and prove it. You can see it counting up, and we get to 1,000,000. So that works, but 7 seconds, the front enders are laughing at us right now, going, you guys are idiots. It takes you 7 seconds to count to 1,000,000. Yeah, it does, but only if we're going to the screen. We're going to do the same thing that the regular developers use. We're going to drop that into a throwaway bucket here, or a throwaway variable. I call it the bit bucket. Everything is exactly the same as the code up here, except I'm diverting the output to a throwaway variable just to make a point. So I'm going to run this. That's a little bit better. Front enders are still laughing at us because they can beat the hell out of that. But that's a whole lot faster. And if we're using this loop to do calculations in the back, oh my God, we've just beat the tar out of any kind of loop. Let's do the same thing here. We're going to drop it into a temp table instead. And whenever I do something complicated or a real pain, you good folks call this a hash symbol. In the United States, we call it the pound sign. So the name of this temp table is Pound My Head. And frequently I do. But let's run this. And what we're going to do is, if the table exists, we're going to drop it. And then we're going to use select into to create and populate the table at the same time, and then add a clustered index. And we're measuring statistics, time, and I/O. And this bit of code right here, all that does is put a line in between without showing the time it took to print the line. So, and I do that a lot in the rest of this code. So we run that, and we can see, all right, it took twice as long to generate the values, but it's also putting them into a temp table. So I can understand it taking roughly twice as long. And then look at here. We had some parallelism going on when we made the index, probably 3, maybe 2, or I'm sorry, maybe 4, but certainly at least 3. The total elapsed time is 370 milliseconds, and CPU is roughly 3 times that. So we had some parallelism going on. Just remember that it was over a second to create that clustered index. And by the way, this is here just so that you can say, yeah, you can see that it's actually got rows. I'm not going to do that to you. They're there. This one, we're going to build the table first and then create the clustered index, and then we're going to populate it. Now, this one is not minimally logged because it's missing a couple of pieces, but I just want to run this for you. So it took 400 milliseconds, both in CPU and duration, to build the table, add the clustered index, and then populate the table so that we're done, all in one piece of code up there, instead of the 1,000 milliseconds to recreate or to build the clustered index after we've done things. So this is one way to make your code run a little faster. Sometimes, as with everything else, it depends. Sometimes it doesn't work, but it usually does. And I'm not going to take the time to prove to you that it's minimally logged, but the thing that makes this minimally logged is this particular database, this JVM test SSD database, is in the simple recovery model. And I have with tab lock, which is a requirement for minimal logging. And I don't actually need this, but one of the things you have to do in order to get minimal logging is, if you have a clustered index, whatever you're putting into the table has to be in the same order. And the minimal logging only works once. It only works on the first insert. If you insert one row, that first insert will be minimally logged, and then if you follow that up with another million rows, that million rows is no longer minimally logged, and even trace flag 610, which was all the rage for a while, it won't do it. One other thing I'll tell you is, if you add a fill factor to that index, there's a nice little anomaly that if you put a fill factor on that index, like say 80%, and then you do this first insert with tab lock, that is the only time that inserts will actually follow the fill factor. And that's really, really important for making test data, because sometimes you are going to build a big table and you want to test something having to do with a fill factor. Well, all you got to do is add the fill factor to your clustered index and make sure that you're doing that first insert as if you're trying to do minimal logging, whether or not you're in the full recovery model or the simple recovery model or what. It will follow on that first insert. It will follow the fill factor for you, so you don't have to rebuild your index after you populate things. Okay. Magnus, any questions?
Nope, no questions.
Good. I think either that or everybody. Well, you guys are at noontime out there, so.
Yeah, we're half awake at least. I mean, some of us are longing for that Friday beer, but we're still at work. So.
Well, and you've had at least one cup of coffee. I'm still working on my first one. Okay. We're going to talk a little bit about readless pseudo-cursors. And this is an intro to table-valued constructors. A lot of people already know about this. We're going to talk about more cross-join power, more minimal logging, building the clustered index before and after like we did before. And I'm going to skip the intro to the f-and-tally function because I already did that. People ask me, Jeff, you never use Hungarian notation like the FN on that tally. And why did you do that on this? And my answer is because I also keep a real live hard-coded tally table in for blinding speed because although it uses more reads, it's still faster than a tally function. And the other thing is it allows me to say, what if somebody says, why is my code slow? I can actually say, well, if you used my f-and-tally function, it's not actually an HR violation. So, okay, so intro to pseudo-cursors. I think we already did this. We did. Oh, no, we have another page here. Okay, so pseudo-cursors. This is a pseudo-cursor just like before, except we're using a table-valued constructor. And what a table-valued constructor is the new way that they came up with using values as of 2008. And so this is actually a 16-byte table that I've created using a table-valued constructor. I'm giving it the alias of E0, and I'm giving the column name that's formed N, and I'm discarding all of that, and I'm saying just do a select one, and none of that matters except this presence of rows. And so if I run that, just like before, I get 16 ones, not quite a million, but I get 16 ones for free. Now, the really cool part is no reads, none. This is kind of the basis of the f-and-tally. I've got 16 ones here, and I cross-join it 8 times. If you break out the calculator, and do 16 to the 8th power, you end up with that monstrous number of 4.2 million again, or 4.3 million, whichever way you want to call it. And we have a select top row number here. Again, row low. Let's see how long it takes to build a million numbers. And you're going to find out it takes roughly the same time as our previous example, because we're doing roughly the same thing, except we're instead of reading from a table, we are getting that for free. There are no reads here. Still took 7 seconds, but no reads. And DBAs love it when you can avoid reads because a lot of people will use reads as an indicator of how bad your code is because of accidental cross joins known as many joins because of you don't have the right criteria. So now let's do like before. We're going to drop it into a bit bucket throwaway variable. And again, this is the definition of nasty fast. Boink. It's even faster than it was before. We counted from 1 to 1 million that quickly. Front-enders are still laughing at us, though. Now, this code is a pain to memorize and to type out or even copy and paste. And that's why we have function tally. This one statement here does the same thing as all this. And don't worry, we're actually going to get to test data here. But it works the same as the other code, and it takes about 7 seconds. But because it uses table value constructors, it also produces 0 reads. Okay, let's see. Why did I do that? I'm getting lost, not enough coffee. That's what I did. Same thing, we're going to do the exact same code except into a temporary table. And you can see roughly the same results that we had with all the other complicated code, but no reads. And what am I doing here? Okay, this is creating the table and the clustered index first and then populating it. Same as before. This one is not minimally logged because we don't have the with tab lock here, but still it's pretty fast. And you can see we didn't use quite as much clustered index time there to build the clustered index. And this is exactly the same code, but we have with tab lock and our order by. And this time I'm going to say option max stop 1. And the reason why I do that is, remember I told you that sometimes it loses its mind thanks to the wonderful improvements in the optimizer. If we run this, we can see we didn't even do any parallelism, and yet it's still, we've cut our CPU time in half. If I comment that out, comment out the option there, the max stop option, and run this again, sometimes you'll be able to see that it actually got a little bit worse due to the parallelism, because it costs some time to do the stream split and then the stream gather. If you're working with 30,000 rows, that cost is still, or I'm sorry, 30 million rows, that cost is still there, but it's much smaller compared to the amount of time saved.
I think I lost you now, Jeff.
Cache on my personal machine.
We lost you for a while.
You don't
there.
want to do that in production. Okay, that's what it was. I heard a beep there, but thank you.
You're back.
Thanks for pulling that up. I'm back. But Checkpoint writes everything, make sure everything's written to disk. Free proc cache clears just exactly that. It clears the proc cache. And drop clean buffers, that means anything that's not currently being used for data that's in memory, it's going to drop it all and you have to reload it. You do not want to run this one in production. This one, sometimes, every once in a while, they'll, you run into a bad parameter sniffing problem, especially if you have a lot of crap code like we do. And if I see that occur, I get warnings for CPU usage and a couple of other things, and I'm running perfmon with a particular chart, and I don't have a problem with doing a proc cache, but I'm also not running the same rates of human interface like somebody like Amazon. Okay. Sequential dates. These are simple. We already know. And I'm sorry, Magnus, do we have any other questions, first of all?
We got some from Luis. I think you need to elaborate a bit, Luis, on it. It's about the 1 million example. Is it safe to randomize the results?
Actually, we're going to get to that. Hold your horses. We're going to randomize the hell out of things. So cool. Good question, and it's coming up.
I just want to point out the time a little bit, because we're on 70 minutes right now.
Okay. This is going to take some time. Damn. Oh, Lordy. me see if I can speed this up. Thanks. Sequential dates, they're really easy. You add the count to a base date, and the hardest part is determining the base date and what the count should be. We're going to do some examples that cover year 2000 to present and a couple of others. And again, we have a demonstration up here. It's on script 30. I'm going to try to blast through these, folks. This first one, by the way, you can have a date, a 4-digit date. If it's a 4-digit character-based date, that will start you at the first of the year for whatever that year is. And so here's a little example. And it gave us our sequential dates. That's the answer to that interview question. And the way this was done was, and all this is leading to the randomized stuff. We added the date. We used function tally to generate some numbers, and we actually started at 0, so when we add t.n to the base date, it doesn't change the base date, and we're just taking the difference between whatever our start date was, and in this case our cutoff date, and we just add t.n to the original date, and that's what gave us our list of numbers. You can do the same thing with a rolling window, and just to show you that works. Now, I don't feel too bad. These are all documented if you want to look at them. This counts counts backwards to the original date. If you want to count forwards, instead of doing order bys, if you change the formula a little bit, it runs a lot faster because you're not sorting on anything. This order by t.n, it doesn't show up in the execution plan, where these things will beat the hell out of your performance. So if you need to sort by these other things and make it so it's in ascending order, use your head, change the formula. And I apologize for running over here, folks. This is taking longer than I thought. Here's an example with 8-hour shifts. You can see it starts at a given date at midnight, 0800, 0800 to 1600, 1600 back to midnight, and it does that all the way down. And the way we did that was we calculated the difference in dates and multiplied it by 3 because there's 3 shifts per day. And I want to talk a little bit about this year start. I pre-calculated year start as part of a separate CTE. This is not a recursive CTE, but it makes a runtime constant so that I don't need to have that formula here, 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 and here. It simplifies the code and it makes that runtime constant. And you also really need to look for modulo. In this case, it will produce the numbers 0, 1, and 2 for shift numbers. And if we add 1 to that, we get whole shift numbers, 1, 2, and 3. Alrighty, when random numbers aren't random, rand generates numbers from 0 up to and not including 1. Mathematically, 0 is less than or equal to rand, and rand is less than 1. You'll commonly get 13 to 16 decimal places back, with 15 being the most common. And it's super useful, but if you don't do it right, it's going to return all the rows, and they'll all be the same random number. Every time you run it, the random number will change, but they'll all be the same random number like that. So let's randomize it. Turns out rand isn't random. It seems that way, but not in a query. It actually needs a random seed, and the only random seed that you can get in SQL Server is from new ID, which is a pseudo-random number. Changes in value for every row, but it can't be used directly in rand. You have to convert it. the fastest and easiest conversion is checksum, which will take a random new ID and convert it into a rather large random integer, but it actually does it faster than even convert int does. So if we do that, we can see new ID, we take the checksum of that, and then that acts as a seed for random. And you'll get different numbers because it truly is random, but you also get different numbers for each row. And that's how you use rand a little bit. But what can we do with that? And that's what we're going to talk about. Random number generators, some simple math. For float, we've already seen this. This checksum new ID generates a random integer, and then we use that as a seed for rand. You multiply that times a range of values that you want, and you add the offset. And yeah, a lot of people are going, what? We'll cover that in just a minute. For random integers, you can just take the checksum or the checksum of new ID again, and you do a modulus using the range, and that gives you minus to plus values, and then you take the absolute. And the reason why you have to do it, take the absolute after the modulus, is because there is a 1 in 4 billion chance, and I've had it several times, of getting the largest negative number, and when you take the absolute value of that, it doesn't work because the largest negative number is one more than the largest positive number in integers. So this range, what is this range? Well, it's real easy, and it's calculated the same way for both. We'll cover that in a minute. What's this offset? It's a fancy name for the start value. A lot of people go, well, you got to have the offset. No, it's a start value, folks. You don't have to make it difficult. So ranges, end value minus start value. That means the end value will not be included. If you want the end value to be included in the range, you have to add 1. Because, for example, you have the values 1 through 10, and if you say 10 minus 1, you only end up with 9 values, so you have to add the 1 back in. So the end value be inclusive there. Same formulas for floats, except the floats are going to include all the values for the end value. What I mean by that is if the range is 100, in floats, the range is actually going to be 100 point a whole bunch of 9s. And the offset in all cases is the start value. Some code examples. Now, we pretty much beat the hell out of things here. Let me just give you a quick example. Start value, end value. We're going to count from 400 to 500. How many values is that? It is not 100. It is 101. Because if you count from 401 to 500, that's 100, but you have to include the 100. Now, in this case, we're not adding the 1, so, and all of this is just some test code. So I'm going to run this real quick for you, just to show you that this works. And these are all proofs, but it works. And it works fast. These are the floating values. These aren't the same values as these as integers. These are separately generated floating integers, and the reason why I wanted to do this was to show you that you can generate both at the same time. You can see the min and the max for the float part, and the min and the max for the integer part. And I'm only going to do this on one of these. You can see pretty much the kind of distribution that you would expect to see for random numbers. They're not all going to be the same, but they're not going to be, drastically different. They're all going to be with that 10,000. Oops, sorry. You can do the same thing with dates. And what I'm going to do is I'm just going to run this instead of all the other junk. I'm sorry, this. Well, I got to include the return. So I have a random date time, just a random date. This portable date and date time and date, that is how you do the calculation if you don't have anything like get date or new ID is the big thing here, I guess. No, not quite. Continuing down, random names. This is kind of lame. And this is the way most test generators that you buy will create random names. Those don't look like names to me, but they're random length. And you can do that if you want, but that looks a little lame. This is actually a better example. This is colors. Now you could have a table with a whole bunch of names that you could download from, say, the Census Bureau from the United States. And these are, excuse me, these are the names of the colors, but they could be names of humans. And to Luis's point, we can randomize the order of these. So you can see we've got a million numbers and they're all randomized. And the way I did that was I can't find it. Oh, here it is. I used a random number to generate the ID of the name that I wanted to bring in. And so this part generates 0 to 8, and then we add 1, and that gives us, instead of 0 to 8, 1 to 9. And so that helps us do that type of randomization. And let's go back. And thank you guys for hanging in. This is, I hope this is going to be worth it. I have this impossible report. We have some generate clean hierarchies, which we may not be able to get to, but I want to show you this impossible report. Let's go to script 50. And the reason why I want to show you this is because it's more like what you're going to do in real life. One of the problems that they
Looks like we lost Jeff for a little bit. Let's see if
they bumped out there for.
I think you're back again.
Yeah, okay. Anyways, they gave me a problem. They said, we got this table with a call ID, and it's just an ever-increasing number like an identity would give. They said, we got call times, and obviously I've changed the dates here, but way back then they said, we have 2 years worth of call times, and back then it was 14 million rows. And we have a CSR ID. We have 100 CSRs. They all have different IDs. So for testing different IDs, it doesn't matter what they are. I'm just going to do 1 to 100. Call code, that was kind of unusual. It's 2 letters long. The first letter can be the letters from A to E, and the second letter can be the letters V to Z for a total of 25 different call codes. And the call minutes could be anywhere from 1 to 15. So here we go to generate that data. I have an ID. This random checksum is the float formula, and the range is from 2019 up to and not including 2021, and the start value is 2019, which, since it's date time, that will be converted to the 1st of January 2019. We have the CSRs here. So there's the integer random number generator, and we're doing percent by the range. That will give me 0 to 99. We add 1, bada bing, bada boom, we have 1 to 100. And then we do the same thing with this call code. It's pretty easy. If we look, both of these use the integer random number generator. And instead of using numbers, I could look up ASCII, but there's a function that will calculate it. So I'm taking ASCII A, subtracting it from ASCII E, and adding 1 to it to get the range for the first one, the first letter, and the starting value is ASCII A. I do just about the same thing, except I start at V, end at Z, starting value is V, and call minutes. There's my 15 minutes. I'm going to create 30 million rows. And I should have started this a second ago because it does take a little time to run. But while that's running, and I also have to create one for the CSRs. But the impossible report was they wanted everything except the kitchen sink by CSR. And they wanted 4 weeks worth, except I tested with 8 weeks. And I could run you through all this. This is not part of the random number generator or the test data generation. This is how I solved it. And this strange beast right here, where I divide by 7 and multiply by 7, and the date diff is on a -1. That's how you calculate the first Sunday of any given week, because the -1 is actually December 31st, 1899 instead of the 1st of January 1900. And then you add that number that's produced. This is integer division. So you divide by 7, that gets rid of the decimal places, and then multiply by 7, and that gives you a nice whole number. And the -1, that date that I told you about, is on a Sunday. And then this is what's known as a crosstab. And it's pretty easy. If you try to do the same thing with a pivot, it'll be a lot more difficult, but the key here is to pre-aggregate the data, and you'll see how beneficial that is. And then some group bys, and I do some special grouping with the row numbers and things. You can take a look at that. But the grouping is to help me produce labels for what turns out to be a report like a matrix in SSRS. So I'm going to run this. And so we're running 8 weeks out of 2 years that has 30 million rows in it. Any wagers on how long it's going to take? That's it. It's done. And that's why I needed test data. I could not have developed this unless I had test data. Maybe I could have developed this, but I wouldn't know for sure that it ran in less than a second. In fact, if we look at messages here, it ran in less than half a second. There was some parallelism involved, but this is the ultimate goal. This shuts everybody up. I was told there is no possible way to do this in T-SQL. We're going to do it in 32 different methods. We're going to use C#, and we're going to use Perl, and we're going to use ActiveX and a bunch of other junk. And the real fact is it can all be done in T-SQL. This is not difficult code, but I had to prove to them that it could be done, and please stop creating a Tower of Babel with these other things. Let me wrap this up. For those people that want to stay on, we can cover these other things, but I've got one for generating 1 million rows for clean hierarchies, and these 2 links here are where I used them at in an article. And the same thing with this generate random CSVs. I just want to show you that real quick, and that was script 70. Okay, so I create a function, and that function, I'm sorry, it's actually a view that I call it's so I can use functions in functions. It'll allow me to use new date and get date inside a function. And then I have this create CSV, and it has this funky loop. This is using old technology. This code is quite old. It's well documented. You can take a look at it. But I'm going to run this, and maybe you'll remember the output. And it takes a little bit to run because it's doing 100,000 times 100 or 110 or 11 million offsets. That was what I used to generate the data that you saw before for that delimited split 4K versus the XML splitter. So everything is possible, and you can go totally nuts. And by the way, a hierarchy looks like that. We didn't cover that, but just a quick review. You don't know about performance until you build enough of the right kind of test data to actually prove it. And if you don't build the right kind of test data, having a ton of test data with a cardinality of 1, 2, 3, 4, 5, that's just not enough. You have to have the right kind of data. And we learned that there's just a couple of basic techniques for building integer and float data, and then you can apply that to dates or letters or whatever the heck you want to apply it to. And we do that in a very high-speed fashion using pseudo-cursors. And we applied those techniques to several code examples, and we learned a new phrase. Say it with me again.
Nasty fast.
Suggested reading, this presentation. Like I said, I write this presentation as a book. Read the documentation and the code. It explains a lot. And look at the code itself. Start looking things up. This could be an all-day presentation, and I overran just in the simple stuff here. This one is, if you want to read the article about how to get things to follow the fill factor when you're doing an insert, and like I said, it only happens on the first insert, that's the article that you can go to. Hidden rebar counting with recursive CTEs, we saw that demonstrated here. Tally table, this is the article that I wrote that really helped a lot of people understand pseudo-cursors and how tally tables and functions work. How to make scalar UDS faster. The answer is you can't. That's why you have to use inline table valued functions. But people test them wrong, and this shows that people do test them wrong. They don't actually take 200 times longer to run. They only take 7 times longer to run, but people test them wrong. And then, of course, articles on generating random integers and floats, and the other one is generating sequential and random dates. Does anybody have any questions? And I'm sorry I went over.
We had some questions more from Louise, but they were all answered just seconds after they were asked. So it was an example of excellent questions.
Yeah, exactly. Good questions. And I was glad I was able to cover them. And that's the other thing is people say, well, how do you know if you had a good presentation? People go, well, I really had the audience engaged. A lot of people ask questions, and I'm going, no, dude, you got it wrong. If people are asking you questions, you're not doing your job. So, well, I want to say, again, thank you to Magnus for doing these SQL Fridays, and thank you guys for having me. And you guys took some time out from your lunch and on a Friday. I want to first say thank you for attending because you're trying to make a difference in what you do and what you do for other people. So thank you very much. And Magnus, I'm going to turn it back over to you.
Thank you. Yeah, it wouldn't be much of an event without the speakers. So thank you so much for waking up in the middle of the night to present for us. It was I'm really glad you did. Slight overdraft of 50%, but we're okay with that, you know.
Sure. I'm old, and so I actually had to get up a week ago to get up in time for this one. Alrighty, so, I think that's a wrap. I'll shut up and let you continue.
Yeah, I'm just gonna end with mentioning that I've filled the schedule for SQL Friday or SQL Friday. Is it called SQL or SQL? I saw a commercial with Bill Gates in it from ages ago where he says both SQL and SQL in the same 1 minute. So I don't know what's correct or not, but I call it SQL. Anyway, SQL Friday in 2020, the schedule is all filled until December 18th, but there is a year after that. So I've opened up the call for speakers for SQL Friday for 2021. So if you are a speaker and you want to have a chance to speak on SQL Friday, just go to sessionize.com/SQL-Friday and submit your sessions. And I look forward to have a hard time doing session selections. And once again, thank you so much for coming to SQL Friday, Jeff.
Oh, thank you. If anybody has any comments for improvements, can they send them to you and you can forward them to me?
Yeah, no problem. Just send them to me. I'll put my email into the chat. Magnus@transmocopter.se. Just hit me with questions. I think you can reach me on the meetup as well to send me messages from there. And I'll relay them. I will put the recording up probably later tonight, and the zip file that Jeff used during the presentation will be included on the page where I upload it. So it's on sqlfriday.net, and then you click on past sessions, and Jeff's one will be on top later tonight.
And again, apologies for not getting into the code at the end very deeply. Overran quite a bit. But study that code. That code is full of information on all the different types of random generation that I've done.
Yeah, and you have excellent commenting in the code as well. So I think it's going to be easy enough to follow. So very good examples. I'm going to... Sorry, Jeff?
I said, all right, Magnus, thank you.
Thank you. I'm going to head off to another meeting at work, so I'm going to stop the recording. But once again, thank you for coming, and thanks everyone who came to this SQL Friday. Next week is going to be with Gail Shaw, who is going to present on the topic on transactions and atomic operations, which I think will be very interesting too. I hope that we will go back sometime to some kind of in-person events, where we actually get to meet and shake hands and stuff like that. But until then, we will live with virtual ones like this and the past virtual summits and what have you. But I hope I will get a chance to meet you in person sometime, Jeff, as well.
Yeah, thank you.
See you all, guys. I will head off. Bye.